Picture this. It's August 2024, and deep within the control room of the James Webb Space Telescope Science Operations Center in Baltimore, Maryland, astronomers are staring at infrared data that shouldn't exist. Evidence of a mysterious planet orbiting Alpha Centauri A, our nearest stellar twin, just 4.37 light-years away. But that's not even the strangest part. Right here in our own solar system, researchers at the California Institute of Technology in Pasadena have spent nearly a decade hunting for something that could revolutionize everything we think we know about our cosmic neighborhood. A massive, hidden ninth planet lurking in the darkness beyond Neptune, potentially 7 times the mass of Earth and 20 times farther from the Sun than our most distant known planet. Today, we're diving into the greatest planetary mystery of our time, the discovery of new worlds that challenge the very foundations of astronomy and raise mind-bending questions about what else might be hiding in the darkness, waiting to be found. Let me take you back to January 20th, 2016, when Caltech astronomers Mike Brown and Konstantin Batygin dropped a bombshell on the scientific world from their offices at the Cahill Center for Astronomy and Astrophysics in Pasadena, California. After months of analyzing the strange orbital patterns of distant objects in the Kuiper Belt, they published evidence suggesting that a massive undiscovered planet was gravitationally shepherding these icy worlds into bizarre, elongated orbits. This wasn't just speculation. The mathematical evidence was so compelling that it sparked the most intensive planetary search since the discovery of Pluto in 1930 by Clyde Tombaugh at the Lowell Observatory in Flagstaff, Arizona. Planet 9, as it's been dubbed, represents one of the most tantalizing mysteries in modern astronomy. If it exists, this world would orbit the Sun at a distance of 400 to 800 astronomical units. That's between 37 and 74 billion miles away, so far that it would take 10,000 to 20,000 years to complete a single orbit around our star. At that distance, even if Planet 9 is 5 to 10 times more massive than Earth, it would appear as nothing more than a faint point of light, virtually indistinguishable from the billions of background stars that fill our telescope's fields of view. The challenge of finding it is like searching for a specific grain of black sand on a beach at midnight while wearing sunglasses. But here's where the mystery deepens. The evidence for Planet 9 doesn't come from direct observation, but from the gravitational influence it appears to exert on other objects. 6 different trans-Neptunian objects, including the dwarf planet Sedna, discovered in 2003, all have orbits that cluster in a way that would be virtually impossible without the gravitational pull of a massive distant world. The statistical probability of this clustering occurring by chance is less than 1 in 15,000, making it one of the strongest pieces of circumstantial evidence for an undiscovered planet in the history of astronomy. Yet despite nearly a decade of intensive searching using some of the world's most powerful telescopes, including the Subaru telescope atop Mauna Kea, Hawaii, and the WISE Infrared Space Telescope, Planet 9 remains frustratingly elusive. While astronomers hunt for hidden worlds in our own solar system, an even more extraordinary revolution is unfolding in the realm of exoplanet discovery. As we speak, in September 2025, humanity has confirmed the existence of over 5,500 worlds orbiting other stars, with new discoveries announced almost weekly. Just this past July, 6 new exoplanets pushed us past the 5,500 milestone, including the mysterious MWC 758c, a world forming within the swirling disk of dust and gas around a young star 500 light-years away, and the bizarre super-Jupiter HD 36384b, a world so massive it challenges our understanding of planetary formation around giant stars. But it's the recent discoveries that have left astronomers scratching their heads in amazement. Take TOI 715b, a super-Earth discovered in January 2024, orbiting a red dwarf star 137 light-years away in the constellation Volans. This world sits perfectly within its star's habitable zone, that Goldilocks region where liquid water could exist on a planet's surface. But here's the mystery. It completes an orbit around its star every 19.3 days, meaning it's tidally locked with one side permanently facing its sun and the other trapped in eternal darkness. The question that haunts astronomers is whether such a world could harbor life. And if so, what kind of existence could evolve in the twilight zone between scorching day and frozen night? Even stranger is the planetary system informally known as 2M1510, discovered in May 2025, where an apparent planet traces out an orbit that carries it at a perpendicular angle to the disk of material surrounding its young star. This defies every model of planetary formation, where worlds are supposed to form from the same rotating disk, and thus orbit in roughly the same plane. It's as if someone took our understanding of how solar systems work and turned it sideways, creating a cosmic puzzle that challenges decades of established science. The Discovery team, led by researchers at the University of Arizona's Steward Observatory in Tucson, admits they have no explanation for how such a configuration could arise naturally. Perhaps most intriguingly, the James Webb Space Telescope has been quietly revolutionizing our ability to study these distant worlds. In August 2024, using its mid-infrared instrument's coronagraphic capabilities, Webb detected what appears to be a planet around Alpha Centauri A, our nearest stellar twin. The observations, conducted from Webb's position at the L2 Lagrange, 1.5 million kilometers from Earth, represent the first potential detection of a world orbiting the closest star to our Sun. If confirmed, this discovery would make headlines worldwide and potentially become humanity's first target for interstellar exploration. The plot thickens when we consider that some of the most mysterious planetary discoveries aren't happening around distant stars, but right here in our cosmic backyard. In June 2025, astronomers at the Institute for Advanced Study in Princeton, New Jersey, announced the discovery of 2017 OF201, a distant object beyond Neptune that may be a dwarf planet with one of the most extreme orbits ever recorded. This enigmatic world takes 25,000 years to complete a single trip around the Sun, following a path so elongated and tilted that it spends most of its existence in the frozen darkness of the outer solar system, farther from the Sun than any other known dwarf planet. What makes 2017 OF201 particularly intriguing is that it was discovered during the ongoing search for Planet 9, raising the tantalizing possibility that it might be gravitationally influenced by that hypothetical world. The object's discovery team, led by researchers Scott Shepard and David Tholen, found it using the Subaru telescope's Hyper-Suprime Cam, a massive 870-megapixel camera that can survey huge swathes of sky in a single image. The fact that such worlds continue to emerge from the darkness suggests that the outer solar system is far more populated and dynamic than we ever imagined, with dozens or perhaps hundreds of similar objects waiting to be discovered in the cosmic shadows. But the mysteries don't end with distant, icy worlds. Recent discoveries have revealed planets that seem to violate the fundamental rules of physics and planetary formation. BEBO P3b, discovered in 2025 through radial velocity measurements, represents the first confirmed planet orbiting two stars that wasn't initially detected through the transit method. This circumbinary world, a real-life Tatooine, orbits a binary star system where the two stars are so close they nearly touch, creating a gravitational environment so chaotic that the very existence of planets should be impossible. Meanwhile, astronomers using the Atacama Large Millimeter Array in Chile's Atacama Desert have detected what appears to be planets forming in conditions that challenge every model of planetary birth. These worlds are emerging from protoplanetary disks around stars so young that they shouldn't have had time to form stable planetary systems. Yet there they are, defying our understanding of cosmic timescales. The mystery deepens when you realize that some of these forming planets appear to be migrating inward toward their stars at speeds that would normally result in their destruction. Yet they somehow survive and continue growing. As we stand here in September 2025, the hunt for new planets has entered an unprecedented phase of intensity and sophistication. The Vera C. Rubin Observatory, currently under construction in Chile's Atacama Desert, will begin operations in 2025 with the largest digital camera ever built. a 3.2 billion pixel monster that will photograph the entire southern sky every few nights. This revolutionary telescope will be capable of detecting objects 100 times fainter than current surveys, potentially revealing thousands of new planets in our solar system and dramatically increasing our chances of finally spotting the elusive Planet 9. But the search isn't limited to ground-based telescopes. NASA's Nancy Grace Roman Space Telescope, scheduled to launch in the mid-2020s, will conduct a comprehensive survey of exoplanets using gravitational microlensing, a technique that can detect planets by the way their gravity bends light from background stars. This mission could potentially discover thousands of new worlds, including free-floating planets that have been ejected from their home systems and now drift alone through interstellar space. The haunting possibility exists that our galaxy contains billions of these orphaned worlds, dark and cold, carrying the secrets of their violent origins into the cosmic void. The European Space Agency's Pluto mission, set to launch in 2026, will monitor over 200,000 stars simultaneously, searching for the tiny dimming that occurs when planets pass in front of their host stars. What makes Pluto revolutionary is its ability to detect Earth-sized planets in Earth-like orbits around Sun-like stars, the holy grail of exoplanet science. For the first time in human history, we'll have the capability to conduct a census of potentially habitable worlds in our galactic neighborhood, answering the profound question of whether planets like ours are common or extraordinarily rare. Meanwhile, advances in artificial intelligence and machine learning are revolutionizing how we analyze the vast datasets generated by these surveys. Algorithms trained on planetary signatures can now sift through millions of stellar observations, identifying potential planets with an accuracy that surpasses human astronomers. In 2024 alone, AI-assisted discoveries have confirmed over 100 new exoplanets, including several that human analysts initially missed. The marriage of artificial intelligence and astronomy is creating a golden age of planetary discovery, where the rate of finding new worlds is accelerating exponentially. Perhaps the most profound mystery isn't whether we'll find more planets, but what we'll discover about the nature of planetary systems themselves. Every new world we uncover seems to challenge our assumptions about how planets form, survive, and evolve. We've found planets orbiting the collapsed remnants of dead stars, worlds with atmospheres made of vaporized rock, and solar systems where giant planets orbit closer to their stars than Mercury does to our Sun. The universe appears to be far more creative at making planets than we ever imagined, suggesting that the diversity of worlds out there exceeds our wildest science fiction dreams. The search for Planet 9 has also revealed something unexpected about our own cosmic neighborhood. It's not the stable, well-understood system we once thought it was. The outer solar system appears to be a dynamic, chaotic realm where mysterious forces sculpt the orbits of distant objects in ways we're only beginning to understand. Whether Planet 9 exists or not, the search for it has shown us that our solar system still holds secrets that could fundamentally change our understanding of how planetary systems work. But the deepest mystery of all may be philosophical. In a galaxy containing hundreds of billions of stars, many with their own planetary systems, are we alone? Every new planet discovery brings us closer to answering this question, but it also reveals the staggering diversity of environments where life might arise. From tidally locked super-Earths to circumbinary worlds orbiting twin suns, the universe has created conditions for life that we never imagined possible. The search for new planets isn't just about astronomy. It's about understanding our place in a cosmos that grows stranger and more wonderful with every discovery. The next time you look up at the night sky, remember that right now, robotic eyes are scanning the darkness for worlds we've never seen, using techniques that would seem like magic to astronomers from just a generation ago. Planet 9 might be out there, waiting in the cosmic shadows for the right telescope and the right moment to reveal itself. Alpha Centauri might host a world that could become humanity's first interstellar destination. And somewhere among the trillions of stars in our galaxy, there might be planets where other beings are looking up at their own night skies, wondering if they're alone in the universe. The age of planetary discovery has only just begun, and the mysteries we've uncovered so far are likely just the tip of a cosmic iceberg. What other worlds await us in the darkness? What strange new types of planets will we discover as our technology improves? And perhaps most importantly, will we find a world that looks back at us with eyes of its own? The answers to these questions are being written right now in the data streaming back from our telescopes, in the calculations of our computers, and in the boundless curiosity of the human spirit that refuses to stop exploring the infinite mystery of space.